Let's start the lesson with an ode. We have an ode to be read. Okay, go ahead.
7.
Okay, go ahead.
Okay, which one?
The
Alex one. Okay, the Alex one. Alex, my classmate, is funny and full of life. That is why we friends.
Woo! Yeah!
Weird is also
Haiku by 7th period.
Pure beauty, really.
What's the other one?
The other one's also haiku, but Captain Colin, the other one.
Follow me on Twitter.
What is the name of this haiku? Error 404?
Yeah, that's the first time. Ready? Error 404. Your haiku could not be found.
7.
Try again later.
5.
Woo!
Yeah.
No, everybody snap.
Let me
Everybody
case
snap.
3.
All right, after that haiku, here we go. Today we're talking about solving exponentials again, but this time, instead of having one exponential on the left and one exponential on the right, this is where we have to use logs to solve exponentials or exponentials to solve logs. Hey guys, I'm going to start you off with a problem that you guys had in your project, and this is the day that we talk about this. Ladies and gentlemen, if I have 5 to the x equals 53, this is an exponential problem where I got to solve for x. My only issue is that this 53, I can't break him down into a base of 5. That's impossible, right?
It's impossible.
So, the technique of making the bases match so we can drop them, that's not going to be effective here. So what do we do? Well, ultimately what we want to do is we want to rewrite this in log form, and by doing so, that'll get rid of the x out of the exponent. So the first thing we want to do is isolate the exponential expression. What is the exponential? Well, it's your base and your exponent. Get him alone. In this problem, it already is an exponential. Folks, what is this written in log form?
Log base 5 with
Log base 5 of 53 equals x. Guys, would you agree we solve for x? Yeah. Now, ladies and gentlemen, I can actually type this in on my calculator and figure out what that answer is as a decimal. But for now, we're going to leave it in what we call calculator ready form.
So that's the answer?
This is my answer in calculator ready form, right? I'm ready to type that into my calculator to get my answer. We won't do any further, okay? Take a look at this next example. If I've got 3 times 2 to the 2x minus 4 power plus 6 equals 27. What is my exponential in this one?
2x minus 4.
Well, my exponential is the base and the 2x minus 4. So it's this whole thing right here I got to get alone. So what should I move first?
Subtract 6.
Subtract the 6.
And divide by 3.
All right, I get 3 times 2 to the 2x minus 4 equals 21. You said do what next?
Divide by 3.
Divide by 3. Sad math. That's right, I'm just sad mapping. I get 2 to the 2x minus 4 equals 7.
Uh-oh.
And now, if I've isolated the exponential, that's where if you look at my steps up above, I want to rewrite the exponential now in log form. Watch what happens when I do this. What would this be in log form? Log base 2
of 7 is equal to 2x minus 4.
You want to see that? Now this x is no longer an exponent. He's easily to get alone. What would I have to do next?
Minus plus 4.
Add the 4 across, so I get log base 2 of 7 plus 4. Now notice this plus 4 is not part of the log, right? The log stops at the 7, right? And that equals 2x. What's the last thing I do?
Divide by 2.
Divide by 2. So I get x equals log base 2 of 7 plus 4 all over 2. And again, this is called calculator ready form. I'd be ready to type it in if I was going to actually care about what the decimal is. If I care about the answer. All right. Ladies and gentlemen, how are we doing on this? Good?
Excellent.
Excellent. Let's do the next one. Ready? On this one, what would I do first?
You would add 3.
Add 3, so I get 4 quantity 1/2 x minus 3 equals 8. Then
Divide by 4.
divide by 4, so I get 1/2 to the x minus 3 equals 2. Then what?
Then log base 1/2 of 2 is equal to x minus 3.
So you're just trying to get the x alone?
Okay.
Wait.
Honey, what does solve mean?
Get an answer to x.
Answer me.
Find the very
Oh my god.
the very
Get x alone.
That's scary.
All right. Hey, now, what is my final answer to this?
You know,
Barkeem, sit down. Give me an answer.
5.
The owl in the front.
Log base 1/2 of 2 plus 3 equals x.
Incorrect.
Oh, you have to simplify.
I know.
The answer is 2. The answer is 2. We have a winner.
That was the basic
Oh,
enthusiasm.
What is the answer?
I was about to say 2. Just because I guessed 2 another time.
Gracie.
Don't
Wait.
Does that make me a worse math teacher? I don't think so.
Mr.
I've
Cobb,
got questions.
All right.
No idea
This
what you
is
just
what's
said.
the answer? Is he going to do the homework?
I don't get it.
All right, folks, take a look at this.
Oh, so close.
At this point, we actually know that this we can do in our head. Would you agree? This 1/2 to what powers 2? That was one of your graphing problems you had to do the other day, wasn't it? Right? Isn't it?
-1.
This says 1/2 to what powers 2. What's the answer?
-1.
I can answer that. -1. And that equals x minus 3, right? Who said how? Did someone say how? No, really. Did someone say how? So if you take a look. Now this problem doesn't say 1/2. I'm just going to do this as 1/2 to what power equals 2. Right? Now, again, we don't like fractions, so what do? We flip them. Doesn't that become just 2 to the negative x equals 2 to the first? Right? So when you get x equals -1 from there, so that's how Lois got -1 so fast, okay? And then from here, you add the 3 across, you get x equals 2. Is that how we got this? All right. Now, again, folks, so we started off these problems in exponential form, but we had to change them into log form to get an answer because we couldn't use that little trick of making the bases match so we could ignore them. All right. So that's how you solve an exponential. The next thing we're going to look at is how to solve a log expression if you only have one log. If you only have one log in the equation. So it's pretty much the same thing as the exponential. The first thing you want to do is isolate the log expression. If my cursor can right there, isolate that log expression first. Then you want to rewrite the equation in exponential form. Then solve for the variable. And then check for extraneous solutions. All right. Let's take a look at this.
Wait, don't.
Don't what?
Bailey, you do now.
Like I'm posting this on the interweb, so. You
I
can,
don't want to go on the interweb.
all right. So guys, what's my log expression that I need to isolate?
X-5?
Starting at the word log and ending where?
At the
At the parentheses, right? So I need to get him alone. So what would I do first?
Subtract 19.
So I get log base 2 of x minus 5 equals 5. Then what? Once I isolated this log, what was the purpose? Exponential, what would that be?
2x.
Now, what's 2 to the 5th?
32.
32. Someone's face is just saying, you know what, I don't learn this way. I just don't. This is no way to conduct a class. And then you add the 5 across, so you get x equals 37. Now, folks, remember logs, you got to check it out. If I put a 37 in there, would you get an extraneous? No, so that's good.
What's our homework?
Huh?
What's our homework?
Your homework is to watch. Okay, let's solve one last problem here. In this last example, I've got log base 3 of 8x plus 1 minus log base 3 of x minus 4 equals -2. The first thing I say to myself is, well, golly, there's 2 logs on this left side, so how should I handle that? Well, we know that we can condense them into a single log, but there's something that you need to think about when you go to condense these. What exactly is the argument of this second log? Well, remember that this log starts at the word log, obviously, and it ends at what the argument is. Well, since there's no parentheses here, the argument ends at that x. So this minus 4 actually is not part of the argument. In fact, he's not even part of a log. So I'm going to do 2 things at this point. I'm going to condense these 2 logs into a single log. So I write log base 3 of, well, one of my logs is negative, so I've got to put him on the bottom. I'm going to have 8x plus 1 over x. But then I have to pass this minus 4 to the other side by adding it across and making it positive 2. Does it make sense how I went from the original equation to this new equation by condensing these 2 logs into a single log and adding the 4 across? Okay, now that I've condensed this into a single log, I can now rewrite this in exponential form. In exponential form, I would have 3 squared equals 8x plus 1 over x. So 9 equals 8x plus 1 over x. Cross multiply and I get 9x equals 8x plus 1. So subtracting the 8x across, I get that x equals 1. If I check to make sure that 1 doesn't produce a 0 or negative argument in my original logs, we're good to go. So the answer 1 sticks. So my answer is 1. All right, let's take a look at the next problem we have here. Oh, look at this. Now this was a question that was on your graphing of logs worksheet that I told you to skip, but here we are. Now that we know how to solve a log equation, let's take a look at how we can use that skill to help find the x-intercepts. I'm given this function f of x equals 2 log base 3 of x minus 1 minus 4. All right, to find this x-intercept, I know that I replace y with 0, so I get 2 times log base 3 of x minus 1 minus 4 equals 0. Again, to find the x-intercepts, or to solve this log equation, I need to isolate my logarithmic expression, which starts with the word log and ends at the argument. So I need to add the 4 across. I get 4 equals 2 log base 3 of x minus 1. I then need to divide the 2 across to isolate the log expression. I get log base 3 of x minus 1 equals 2. And now I'm ready to write it in exponential form. In exponential form, this would say 3 squared equals x minus 1 simplifying the 3 squared, I get 9 equals x minus 1. And so x will equal 10. Plugging 10 back into my log expression, 10 minus 1 is 9. That's a nice positive number, so I know that it exists. So my x-intercept is simply 10 comma 0. And that's how you can solve for the x-intercepts using this log solving skill. That's it for today. See you tomorrow.